Welcome to the Indian Ocean World podcast.
Hello and welcome to the Indian Ocean World podcast. Thank you for downloading. My name is Renee Manderville, a project manager at the Indian Ocean World Center, or IOWC, at McGill University. I am joined by Archisman Chaudhuri, a postdoctoral fellow at the IOWC.
Hello, Renee. Thank you for having me. You will hear from me more with some questions towards the end of this podcast.
Our guest today is Philip Gooding. Philip is another postdoctoral fellow at the IOWC. He got his PhD at SOAS, University of London in 2017, with a thesis entitled Lake Tanganyika, Commercial Frontier in the Era of Long-Distance Commerce, East and Central Africa, circa 1830 to 1890. He has since published articles in Slavery and Abolition, the Journal of African History, and the Oxford Research Encyclopedia of African History. He is a managing editor of the Journal of Indian Ocean World Studies and an editor of the Indian Ocean World Center Working Paper Series. Today, he is going to discuss one of his recent publications with us entitled Tsetse Flies, ENSO, and Murder, the Church Missionary Society's Failed East African Ox Cart Experiment of 1876 to 1878, which was published in the second issue of the first volume of the new series of Africa, Rome, last year. Philip, thank you so much for joining us.
Thank you for having me.
Firstly, could you give us an overview of your paper? What is a tsetse fly? What is ENSO? How are they related? And how did they affect ox cart transport in the late 19th century of East Africa?
Well, the intention with this paper was to contribute to a new understanding of a relatively well-known aspect of late 19th century East African history, in light of recent climatic research. And this history is the history of the London Missionary Societies and the Church Missionary Societies and Philippe Broyon's ox cart experiments of 1876 to 78. I say this is a well-known history. Not much has really been written about it, but anyone who has entered into graduate study on 19th century East African history will be familiar with it. The documents referring to the ox cart experiment are right at the beginning of both of the London Missionary Society and Church Missionary Society archive as they first began to become established in East Africa in the late 1870s. Broyon's experiment is slightly different. Philippe Broyon was a Swiss trader seeking access to markets, most notably with Mirambeau, who was a state builder in East Africa's deep interior. We know a little less about that, but yet the LMS and CMS both refer to his experiment too. Essentially, the LMS, Broyon, and the CMS sought alternatives to using African porters to carry their goods from the East African coast into East Africa's deep interior, where they wanted to set up mission stations. And their first inland goal was a town called Mpwapwa, about 250 kilometers inland. They decided to experiment with ox carts because of their experiences mostly in 1876 with African porters. Their experiences were not positive. They believed that African porters were lazy. They felt that African porters were perpetually cheating them. In reality, from benefit of hindsight and a critical eye, we can just say that the missionaries just didn't understand the customs related to porterage, and their views were colored by heavily racialized thinking. Thus, they decided to find alternatives to African porters, and they settled on ox carts for the most part, although some did experiment with other animals such as camels and elephants as well. Ox carts for them were also a symbol of civilization. And they very much had a view that the missionaries had a broader view of bringing Christianity, commerce, and the idea of civilization to East Africa for the first time. And certainly ox carts were a part of that. East Africa at this time had not developed wheel technology and did not put oxes to work in any form. For example, with ploughing. And again, this idea of bringing this technology was brought with the idea was for bringing civilization in big inverted commas. And again, this can be related to some very highly racialized thinking. Up to the publication of my paper, these kinds of racialized ideas were seen to have fundamentally undermined the ox cart experiments, resulting in their failure. The failure of these experiments was attributed to Europeans' inability to comprehend African peoples, cultures, environments, customs. And this, yes, as I said, resulted in the ox cart experiments' failure. The environment here is key. Oxes, which were drawing the carts, they died of trypanosomiasis, more commonly referred to as sleeping sickness. And this disease is carried by tsetse flies, which are small flies around of between about 0.5 to 1.5 centimeters in length. And they are endemic to much of equatorial Africa. After the failure of the ox cart experiments, the missionaries and other Europeans based in East Africa, mostly in Zanzibar, declared that ox cart travel in equatorial East Africa was impossible simply because tsetse flies who carried trypanosomiasis were present in the region. And historians, for the most part, have accepted this summation. My paper questions it. While not disputing the missionaries' flawed ideologies and their flawed thinking that led to the development of the ox cart experiment, I actually think there could have been a route to success based on what they say they did if the ox cart experiments had been tried in any other years than 1876 to 78. And my reason for this argument is because the experiments coincided with a major global climatic anomaly. This was one of the largest ENSO anomalies in known history, alongside a concurrent positive Indian Ocean dipole in 1877 to 78. So what is ENSO? ENSO is an abbreviation for El Niño Southern Oscillation. It is an anomaly of sea surface temperatures and atmospheric pressure in the East Central Pacific Ocean. On a global scale, it is usually associated with drought. Positive El Niños, when sea surface temperatures are above average, are associated with drought in, for example, northern China, South Asia, Northeast Africa, Southeast Africa, and Brazil. And all these regions experienced drought during the 1877 to 78 El Niño. But East Africa's relationship with El Niño is different. Positive ENSO anomalies are associated with excessive rainfall and floods, particularly when the anomaly is of the scale as it was in 1877 to 78. Meanwhile, 1876, when these ox cart experiments were beginning to be, when they started to be conceived, 1876 was relatively dry. In 1876, the London Missionary Society and the Church Missionary Society took on provisional runs, taking oxes without their carts into the interior just to see if they could survive. The CMS even carved out a wagon track for when they returned. And these provisional runs were successful. However, when they returned in 1877, the region was much wetter. The region between the coast and Mpwapwa was referred to as a swamp. The two major rivers between the coast and Mpwapwa on the route of the wagon track, that is the Lukigura and the Mkundi, were flooded, making crossing them, even without ox carts, very difficult. And of course, this meant they were stopped for long periods in single locations. And also it meant that the ox carts frequently sunk into the mud, making travel, even in relatively open country, very difficult. At the same time, the wetter conditions contributed to what I think I've identified as an explosion in the number of tsetse flies in the region. Tsetse flies idealize cool, wooded, shaded, humid areas. In such conditions, they reproduce every 7 to 11 days. Swampy conditions, flooded rivers, causing water to enter more shaded areas. These are the kind of conditions that they absolutely love. And this is the conditions that were caused by the excessive rainfall associated with the ENSO anomaly of 1877 to 78. Thus, where the CMS ox carts were stopped for the longest time, that is, on the banks of rivers waiting for them to recede, was also where tsetse flies were at their most numerous. I contend that in a normal season, without the global climate anomaly, the CMS experiment could have succeeded. There are further evidence for this. African populations frequently pass through the region with cattle. There is a significant trade in cattle between the deep interior of East Africa and the coast. Thus, the presence of tsetse flies in general did not inhibit at all traveling through the region with cattle. Moreover, I think the potentialities of the CMS's experiment were more than for the LMS or for Broyon. The CMS departed last of these three experiments, and they sought to learn from the others. They used significantly lighter carts, and as I said before, they attempted to carve a track. They didn't use all the tricks available that could have quickened their pace through the region and limited the chance of infection with trypanosomiasis from tsetse flies. Locals also often traveled with their cattle at night, so the tsetse flies couldn't see their cattle. And they also used natural insect repellents, such as smoke or manure. But it's possible that with subsequent attempts, they may have learned these methods and been able to may have been able to lead a successful experiment in a subsequent season when there wasn't such a massive global climatic anomaly. Why didn't they attempt a subsequent experiment? Partly because they decided as a result of the failures that it was impossible, but also because of the third aspect of the primary title of my article, that is murder. In late 1877, local populations killed some CMS missionaries based on the southern shores of Lake Victoria. The leader of the ox cart experiment, Alexander Mackay, had his role changed dramatically and very quickly. His new task became to re-establish the mission further inland and not to dwell on what might have been with the ox cart experiment or how he might have been able to improve their experiment for a further attempt in the future. In any case, the overall point here is that it was not just European incompetence and ignorance that led to the failure of the 1876 to 78 experiments. It was also because their experiment occurred at the time of a once-in-a-lifetime global climatic anomaly that hindered wheel transport and led to an explosion in tsetse fly numbers.
Wow, thank you so much for that. That's very interesting. I see how you've inserted a global climactic perspective into a history that is more traditionally known for its human, animal, and technological components. Just a quick first question before I leave it to Archisman to ask further questions. Do you think that if the CMS had conducted the ox cart experiment in any other year that it would have been successful?
It's a good question, and not one that I'm not particularly comfortable answering. I certainly leave the question open in the article itself. of course, any answer to this question is based almost entirely on conjecture. If we have the counterfactual, let's say this global climatic anomaly did not occur in 1876 to 78. No, I don't think it would have been successful in that year, not with their first attempt. The CMS cut their wagon track in mid-1877, just before the planting season. When they returned with their carts, much of it had been planted over by farmers. And apart from the wetness of the soil causing sinking into the mud, the fact that a lot of their wagon track had been planted over caused significant delays. Additionally, I don't want to lose sight of the overall aim of the missionaries either. Their plan wasn't just to get to Mpwapwa. That was just their first destination. They wanted to get as far as Lakes Tanganyika and Victoria, well deep into the East African interior. As I said, Mpwapwa is about 250 k's into the interior. Lake Tanganyika is about 1,000 at its closest point. Closer to Lake Tanganyika in particular, tsetse flies were more numerous year-round, even in dry seasons. Thus, it is likely that even if they're successful in reaching Mpwapwa in 77 to 78, they would have had to abandon eventually before they reached their ultimate goal. However, if they re-attempted their experiment in another year, having learned from their mistakes in 77 to 78, and when climatic conditions were more favorable, I think there could have been some success in subsequent years, certainly for the first leg of their journey into the interior between the coast and Mpwapwa. It is notable, and I do note this in the article itself, that between 1879 to 1884, so the 6 years immediately after the oxcart experiment, in 5 of those 6 years, there was below average rainfall in the short rainy season, the time at which they were traveling inland. Thus, certainly climatic conditions could have been more conducive to oxcart travel, certainly between the coast and Mpwapwa, and possibly a little further inland into some arid areas. But once it gets a bit further inland, around Nyamwezi, closer to the Great Lakes, which is a lot more fertile, when tsetse flies are a lot more numerous, I think they would have had to abandon once they got that far, no matter what.
Thank you, Philip, for this wonderful talk. Would you also please discuss the wider implications of this research? Firstly, in terms of the impact of the 1877-78 ENSO event in African and Indian Ocean world history.
Some aspects of the 77 to 78 ENSO event are relatively well known, at least to climate historians and historians of the Indian Ocean world. It is one of the largest ENSO anomalies in known history, and is associated with what Deepti Singh and his colleagues refer to as a global famine. As I said, there was significant drought in Brazil, Southeast Africa, Northeast Africa, South Asia, and Northern China. And collectively, these droughts can be related or associated with around 50 million deaths. I suppose my paper shows another side of this, looking at a region, few though there are, that usually experience abundant or overly abundant rainfall during ENSO events. The human impact is clearly less significant in East Africa, at least in this instance. And we're not talking about deaths of millions of humans in East Africa during the 77 to 78 El Nino climatic event. And there's no way I can make a claim that the failure of 3 oxcart experiments had such an impact on human history as droughts and famines that led to around 50 million deaths. Well, I think what my article does show in a broader context, I think, is a non-human element. That climatic anomalies such as this one have impacts on insects, cattle and cattle diseases, And these also affect human-animal, human-environment relationships. And this is something that I and my colleagues have been exploring in more depth elsewhere. Some shameless self-promotion here. Myself, Martha Chaiklin, and Gwyn Campbell have an edited volume coming out with Palgrave later this year entitled Animal Trade Histories in the Indian Ocean World. And this very much tries to explore, as part of it, shifts in the relationship between humans and animals in the Indian Ocean world. And the environment is definitely, the environment and environmental change is definitely an integral part of that.
Well, that's really interesting. If we were to build on that, how could an understanding of this extreme climatic event have implications for the longer durée of African and Indian Ocean world history? That is beyond the years 1876 to 1878.
Yeah, I think there are some implications we can explore here. My current intentions are to explore more closely the ways in which climatic fluctuations over the long term and climatic anomalies over the short, such as the one described here, have affected East African history. And when you do that, or when I do that, you're inevitably linking yourself with the Indian Ocean world. Rains in East Africa come from the east. They come from the Indian Ocean. They are tied, they're brought by the Indian Ocean monsoon system. There are several ways in which this can be taken. One of the more popular ways, one of the interesting ways, certainly to, I think, the wider academic world focusing on the Indian Ocean world, is to look at security and political instability and how they're affected by climatic change, climatic fluctuations. Certainly this is a concern in the present with global climate change and how global climate change may result in political instability. But I suppose to keep this more, keeping this discussion a little more closely tied to the themes that I brought up in my paper and earlier in this podcast, let's talk about insects. And I'm going to do this also because I think it's particularly interesting in the present. What is going on right now in Eastern and Northeastern Africa, where swarms of locusts are threatening food security in Kenya, Ethiopia, South Sudan, and Somalia, essentially by damaging crops. And this is even being felt in the Middle East and parts of the western part of South Asia as well. In Eastern and Northeastern Africa, essentially this year's, so from 2019 to 2020, and they're the largest swarms in about 70 years. And this has been associated with overly abundant rainfall caused by a significantly positive anomaly in the Indian Ocean dipole. When I say the Indian Ocean dipole, here I mean sea surface temperatures in the Indian Ocean. A positive anomaly is when the western half of the Indian Ocean is significantly warmer than the eastern half. And this occurred concurrently with the 1877 to 78 ENSO event as well. But this positive Indian Ocean dipole has contributed to overly abundant rainfall in Eastern and Northeastern Africa and flooding in many regions, which has helped to improve the locust habitat, causing them to multiply and spread rapidly throughout the region. Of course, there are some significant parallels with what I described in the paper here. We're talking about a global climatic anomaly, overly abundant rainfall, and the explosion in the numbers of insects. My paper discussed tsetse flies in 1877 to 78. In 2019 to 20, we're discussing locusts. If we think about this over the longue durée, as your question alluded to, we can think about perhaps a longer term pattern of floods and insects and possibly insect-borne diseases in East African history that I think is yet to be teased out, at least from a longue durée perspective. To investigate this further, and it's something that I'm certainly thinking about doing, Probably need to also look at Tsetse fly numbers in the present, in the 2019 to 20 anomaly, as well as other insects as well, such as mosquitoes. Again, broadly speaking, mosquito numbers are known to grow in periods of abundant rainfall. And this contributed to epidemics of malaria at various points. And this applies in African, South Asian, and Southeast Asian history. Additionally, we need to investigate other major climatic anomalies characterized by floods in East Africa. I mentioned obviously 1877 to 78. Also, we have the one that's been enduring since the end of 2019. The other major ones to consider would be 1960 to 61 and 1997 to 98. And again, the latter is associated with a significant positive ENSO anomaly.
Wow. Thank you so much for your answers to our questions. That's all the time that we have today. And thank you once again for joining us, Philip. Thank you to Archisman for his additional questions. And thank you so much for all the listeners who have joined us today. Once again, my name is Renee Manderville, and you've been listening to the Indian Ocean World podcast.
The Indian Ocean World podcast would like to acknowledge the generous support of the Social Sciences and Humanities Research Council of Canada. This podcast series is part of the SSHRC-funded partnership project Appraising Risk, Past and Present, interrogating historical data to enhance understanding of environmental crises in the Indian Ocean world.